This is problem 10 in chapter 2, which is a problem that asks you to find the force F2 that will cause this tower to be only under compressive forces or downward forces. What that really means is that the sum of the forces to the left and to the right, or the sum of the forces in the x direction, must be equal to 0. Since this is a concurrent force system, all of these forces are concurrent about this point right here, I'm going to construct the table that we've used throughout chapter 2 in looking at the resultant of concurrent force systems. So for the 50 Newton force, it acts at 0 degrees. When I break it into its x and y components, I'll find out that the x component is 50, the y component is 0. The 80 Newton force acts at an angle that I'm going to call negative 60. And when I do that, the x component will be a positive 40, and the y component will be a negative 69.3. Finally, my F2 force acts at an angle of 220 degrees. When I break that down into its x component, I'll find out that it's 0.766 F2, and its y component would be negative 0.643 F2. Now really, what this problem deals with is just finding F2 such that the x components will all balance out, or all come out to 0. So basically, what I want here is to solve this equation in the x direction, which basically, in the x direction, I have 50 plus 40 plus 0.766 F2, and I want to solve that equal to 0. When I solve that, I will find out that F2 comes out to be 117.5 newtons.